Hi Caroline, this is Sean O'Neill with GD3, and this is networking CA1 Screencast. I've got to demo my load balancer. Here I'm going to give a quick walkthrough of the code first. I have my HTTP request class, and this is the code that you gave us, so it's pretty self-explanatory. I didn't actually add anything to this except for the get the timestamp method down the very bottom, and that's just it's used at the bottom here, and I was going to use it to, when you get your request, that you're going to get the time the thread finished. So when it's closing, as everything's closing down, it gets a timestamp that tells you when it's finished. It's just going to print out like a top timestamp and get the date or the time of the day that it stopped, and then it's just going to, like, this top part here is just a system.out.println, so it's going to print it out in the console down the bottom, and then this is going to write it to file, so it's going to have the same thing just written to file, except this has finished at as well, because there was an error with the casting. So with the write to file I had to write a string, so doing it like this allowed it to be a string, so I just wrote finished at there. In my web server I have it implementing runnable, so I can have so it has a run method that can be ran. Here I have my variable declarations, so I've got my count, my server socket, and boolean that allows it to carry on later. I've got my constructor here for a web server object. It takes in a string, which is the local host, and an int, that's the port number, and it'll throw an IO exception. Here I'm taking the socket and creating, so this dot socket, it's up here, taking that and setting it as the port number, so that you take in the port number here and then set the socket, the server socket, as that port number, and then you get the inet address, which is just the address that you're getting it by name, so you're passing in a string here, which is the local host, and that'll lead you to the address, that's the URL. And then I just have a system.out.println for debugging that says, yeah, created the port and the port number. Then we move into the main method, which I have the starting port number is 1999, and then the next port I have is 2000, and then I've got the local host is currently, the string is just localhost. I got this code here for creating a thread pool for when you're threading your clients, and I got it from this website here, and it explains how to use it there. But I'll give a quick run through here. It's you're using executors or executors, and you just get to name it here. I named it pool, and then you're making a new cached thread pool, and I used a cached thread pool as opposed to another one because this is dynamic. Other thread pools I've seen are fixed and you have to choose the size. This cached thread pool creates a new thread. If there's no threads open, it will create a new thread and feed the new request into that thread, and if there is a thread that's idle for 60 seconds, it'll kill it off. So it seems quite nice. It's able to clean itself up, and it can give you all that you need, like any amount of threads that you need. So it's said in the documentation on this website that it's really good for short bursts of many processes, and that's kind of what we're doing here. So I thought it was ideal for it. So I have a for loop here that creates new instances of the server, so this is where I'm making new servers. So this actual web server here will be the DNS, but these will all be the actual servers, so that other server will redirect you to one of these that it makes. So it's taking in the web server, regular stuff, the local host and the port for the constructor, but the port it's taking in starts at next port and then adds I. So it starts at 2001 and then it goes to 2005, and they're the port numbers. And then I'm calling pool.execute server, which creates a new thread and starts that thread, for this server here, the web server. And then I go down to a while loop, and this carries on while it's true. And then it just says that the port and the socket local port are listening, so you're just getting the port number from the socket, and you're saying that that number is listening. and then I go into a do loop here, and then it's just that says that if the next port is 2005, set it back to 2000. So then it's just, and then you increment it here. Every time you go through, you increment it. So it'll just be when you're out of servers, to say, you know, so you've gone around and you're at your last server, you just loop back around to the first one, and then you can go through again. So it should just keep resetting it when you reach your last server. Then I'm getting my accept here, which is just to accept the connection whenever something makes a connection attempt to this socket. And then I'm incrementing my count, which is here. I'm getting the INET address connection for the connection, this connection here. Just getting the INET address for that, and then the HTTP. I'm creating a HTTP request called request, and passing in the connection, the socket, and then I'm creating a new balancer, which is my load balancer up here, which I'll move on to soon. Creating a new one of those and handing it connection and the next port, so it'll try to connect to that port. And then here is when I'm creating a new thread to run that on, and it'll run request, the new request off that new thread. And then I'm starting the thread down here. And then this is just if you've done this, so I increment count here as I'm going through my while loop, and then if count equals 20, then you turn it to true and you break out of it. So you can't continue on doing this loop while it's false, and then you turn it to true if it's reached 20. So pretty much it just goes through 20 iterations. It does this 20 times and then just kicks out. The balancer is my round robin implementation class, so it just kind of, it gets an incoming request to the web server, and it tells the request where to go. So it implements runnable as well, because I wanted a run method with it. And I've got just some variables, socket and port here, and then I've got my constructor for it here. So it takes in a socket and an int, which is a port number, and just sets them to equal these here. So that allows me to get them in the scope of this class. And then I have my run here. The run's pretty short. It just tries to process the request, which is this method here, tries to do that. And if it can't, then it just throws an exception and prints it out. The process request, pretty much, it creates a new input stream, and then it gets the socket's input stream. So pretty much it gets what the socket's requesting, and then using an output stream, it gets its output stream as well, the socket's output stream. So that should be where you want it to print. And then I've got a print writer, which I actually don't implement in this, but that would just be to print it out, to actually print it out of the file. I've got a buffered reader to add a buffer to the input stream. So if you want to have padding on either side, you can do that, or you want to set up a certain amount, so say you only want 1024 characters in your input stream, and then you want to flush it, that's what you can do with the buffered reader. And then I get the request line. So you just read this line here. You read the line of the buffered reader, which is the input stream of the socket. The request line is a variable name, and you're just pretty much reading the next line. You're finding out what it's looking for. And then the tokenizer is some of the code that you gave us, and it just, I think, allows you to extract the file name. So you parse through it and you look for the file name, and then you take that out, and then you move on. So you skip over the next lines, and you make the file name equal to the file name that you pulled out using the tokenizer. And then here I have get thread timestamp, which is down here, which I'll get to in a minute. Then it sends a reply, which is just localhost, and pretty much it tells you where you're redirecting, and it should say here that you've redirected to here, which is your reply. So it should say, localhost, the port number and the file name, and then the log file is just writing it out to file. And then you close your writers and readers, and then you close the socket. And then here the get thread timestamp is you're using a date utility, getting the stamp, which is what I called it. and then you're just writing it that you started the thread or the socket. You started the thread at stamp.getTime, so you're just getting the time. It's a very similar timestamp to the one I used I used the HTTP request. My CA client is just a way of calling the client thread. It's pretty simple. It's just kind of a shell class. So it's got its main, and then you create a new client thread, and then it just says, you know, you have your for loop. So if it's between 1 and 10, so I think I'm creating 9 new threads. You run, which should run CA client thread and create a new thread for a client. And then in client thread I've got my string here, which is the user agent, which I think you gave us, which was just, it says what browser you're in, or the browsers that are available. And then we have the run method here, which is what gets called from the CA client. And here I have my URLs for the 3 different web pages. So they're all on the same port, but that'll get redirected later, as it should get redirected in the balancer. And then you just go to, say, example web page 1, example 2, example 3. And then here you try to create a new URL link, and then you feed in URL, which is currently this one. And then that would loop around and go to 2 and 3 if you're creating new requests. You create a HTTP URL connection here, and you open that connection with this URL. So that should pass you to that one. The buffer reader here I actually haven't implemented either, but that's similar to the one in Balancer. You're getting the input stream, and then you're getting the input stream for the HTTP URL connection, and then it just does the same. You want a response message, you get the response message here, and then you tokenize it, you parse through it and look for where you're going, and then you get the redirect and you pass the reply up. And then here you create a new URL object called object, I just call it object 2, and that is that opens with your redirect URL. So this will be the URL you're redirected to, so you know, port 2001 or port 2002 or whatever. And then you get a new HTTP URL connection, and you open the connection with object 2, which is the new URL. And then you want to do a get, so you can get the data, because that's, I think, basically what HTTP does on the internet. So you pass in get, and then you pass in the user agent stuff. So that's up the top, what browser you're using and all the codes. And then this just pretty much sends a get request to the URL, and this tells you the response code. So it tells you what you got back, and this is just your request that you're sending to the new URL. And then we want to just look at what we're getting back here, and the delimiter here is used to show when you've reached the end of file, and that's CA client thread. And then the log file here, I got a bit of assistance with this class from Audrine. She's in computing 3, because I wasn't quite sure how to write out from file. So the log file here, just this class here, it's here is where you have your variables. So you're starting up a new file, so that's your file path. So that's where you're going to actually print this out to. And then you're setting up a file writer, so that's what we'll actually write out to file. Here we have the write to file function. So the file writer, you create a new file writer, and then you give it in the path that it's going to print out to. And then the true means that you don't wait for the buffer to be full before you flush it, you just flush it straight away. And then you catch the exception. And then if the file doesn't exist, you create a new file, and then otherwise you just write the info which you pass in, you write that out to the file, and then you format it using these 2 arguments here, and then you flush the buffer again just to make sure that there's nothing in it, so everything's written to file. And then here you attempt to catch the exception again. And now I'll demo my code in the next part of my